Since I was young, my favourite games have been those in the Metroid Prime trilogy. The exploration appealed to my sense of curiosity, the isolation mirrored my introversion, the worlds were vast and alien, the power-ups felt sleek and futuristic. Over the years I've made several attempts to partially or fully recreate the look, feel and fun of these games, with little success. Either I lacked the technical skill, poorly planned the task, overestimated my scope, or more often than not, some combination of these factors. My efforts were always ill-fated. However, with a number of years of game development practice now under my belt, and having released a small handful of short games, I now feel I'm up to the task of paying homage to one of my main inspirations for becoming a game developer. During the summer of 2020, my friend and I took part in the Brackeys Game Jam, and for our entry my friend suggested we try and use a new physics-based first-person player he'd been prototyping. As we worked on this player concept, it dawned on me that the player moved an awful lot like Samus in the Metroid Prime series, and while our submission was far from the winning entry, we did get praise for the player movement. This was the initial genesis of what would become MOCKTROID. Initially, I wanted to make a 3D version of my 2D Metroidvania template, however this quickly morphed into using a Metroid Prime style game as an example of gameplay mechanics and systems that had a wider field of application in games across multiple genres. As previously mentioned, the player was devised in our Game Jam project, so it was a natural starting point when the time came to start prototyping MOCKTROID. The player controller is wholly physics-based and mostly boils down to a capsule component stacked atop a sphere that is pushed in a desired direction, with everything connected to the sphere rolling along atop it. I can then apply different levels of friction using a physics material to make the controller as tight or loose as I like. This is how I created the morph ball movement. Instead of making the ball its own controller, I instead pull the camera back and switch to a different instance of the physics movement with different values for aspects such as speed, as well as swapping the physics material to create a controller that will roll more freely. Using this method of control means I'm not dependent on Unreal Engine's character movement system, which is great for introducing people to the engine, but can cause issues such as differing jump heights with frame rate further down development. From here I created a simple shooting component using Unreal's included projectile movement system, and I had a working facsimile of Samus from the Prime games. One of the core aspects of any Metroid game is its web of interconnected rooms that seamlessly load in and out, creating the illusion of a vast continuous world. To effectively achieve this myself, I decided to utilise Unreal Engine's level streaming system that loads individual levels into a container map called a persistent level. Mastering Unreal's level streaming has been a personal goal of mine since my first year of university, after one of my tutors told me about its relative complexity. In previous projects I utilised pre-made assets called level streaming volumes, which I placed in the persistent level, having them load a room once the player entered their bounds. This system however came with a number of issues, such as having every one of the room's level streaming volumes contained in the persistent, and issues with pop-in should the volumes be too small. With my previous system's issues understood, I put considerable effort into designing a new system that would be more efficient and user-friendly than placing and sizing volumes by eye. For inspiration I turned to my initial source for getting into game development, Metroid Prime speedruns. I find speedruns to be a valuable tool in finding out the inner workings of a game, as runners often explain the functionality of a mechanic and why they're exploiting it to their audience. And after countless years of hearing runners explain out-of-bounds movement in Prime, I had a small epiphany. In Prime, every room is contained in a box, and the walls of the box are considered sticky. Inside the box, the game's physics are applied as a performance-improving tactic. Speedrunners use the sticky walls to climb to areas they're not supposed to, however they must hit certain load triggers to make sure that the room they're going to is loaded, and other rooms are unloaded from memory, as having too many rooms loaded can cause crashes. This idea of containing a room in a box is similar to my previous level streaming solutions, but my new solution would make use of a component called level bounds that will automatically scale to the size of a given level. Unlike Retro Studios in 2002, I don't have to worry about loading too much into memory and causing crashes, thanks to the vast amounts of RAM available to modern computers and consoles. So I utilise the room's level bounds to load in levels. The system works like this. Every room is contained within a box, and each box has two string arrays assigned to it. When the player steps into a room's box, the box sends the contents of both arrays to the game state, which persists while the game is running, making it useful for passing information to. The game state will stream in all the levels with the names stored in the first array, and unload all the levels with the names stored in the second array, creating a system that acts like a chunk loader, giving the illusion of a continuous world that is in fact made of several rooms stored as individual levels. Thanks for tuning into the first devlog for this project. I hope it gave an insight into the inner workings of my initial prototype for the project. I have a devlog creation plan for the end of every other sprint, so video updates should be coming out every month or so.